All right, this is going to be our last section for our unit. This is 3.7 points of concurrency. Okay, and these are all associated in triangles since we're in the triangles unit 4. So concurrent, what does that mean? To be concurrent is when a set of lines has one point in common, okay? This is going to be the topic of our whole investigation of this section, points of concurrency. So the word concurrent means when 3 or more lines have a point in common. So here's an example, a picture, and draw this picture onto your notes of what it looks to be concurrent. And so we call that the point of concurrency. Don't draw these pictures over here, but these are examples of what lines that are not concurrent, okay? So like I said, we're going to be working with concurrency through this whole lesson. So the first investigation is called the angle bisector concurrency investigation. So we're going to construct the 3 angle bisectors, okay? So feel free to pause the video and construct the angle bisectors and then kind of carry on after that, okay? So I'm going to do that right now. I'm going to make the 3 angle bisectors. And so you know you have to start off by making an arc on each angle. You're going to do this for all 3 angles. Okay, and then once you do that, you'll use your ruler to make it. I'm going to go make all the arcs first before I So angle bisectors, you guys constructed pretty easily. Okay, so now I'm going to get my ruler and I'm going to make each angle bisector. Now here's where you want to be real precise and make sure it goes straight through the intersection points. Okay, so you want it to go right perfectly through those. Because if they don't, then it won't come out right. Okay, so there's one. I'm going to draw all 3. 2, and 1 more. Make sure, again, you're perfectly at each angle. Okay, so did you draw all 3 angle bisectors? Okay, what do you know? Look at that. Okay, get a highlighter or something and highlight how they all intersect at the same point. So guess what, guys? That point right there is called a point of concurrency, okay? So that is a point of concurrency, and we're gonna write down in the first blank that yes, the 3 angle bisectors in a triangle are concurrent, okay? And then each point of concurrency actually has a name. So there's gonna be several that we have here today. Point of concurrency of the 3 angle bisectors is the in-center, okay? So that's the in-center. So there's something also unique about the in-center, okay? So this is the second part of the investigation. It says then measure and compare the distance from the in-center to each of the sides. Remember to use a perpendicular distance. And how do they compare? Okay, so perpendicular distance, what they mean by that is get your ruler, and I'm going to let you estimate. Usually we should construct, but I'm going to let you estimate. And so get your ruler and draw the perpendicular distance. I'm going to get a different color from there to the bottom. Okay, and so that's how far it is to that edge, to that side. So what I want us to investigate is place your compass on there. Get the measure of that right there, and I want you to kind of compare it to the others, okay? And it should be, if we did this right, should be going perfectly through. Okay, you see how my circle's almost perfectly the same distance to each edge, Okay, so really what should have happened, it should have looked something like that. Okay, so where the circle touches each edge perfectly. Okay, of course I have this digital smart notebook and it doesn't always work out, but yours should come out nice and perfect. Okay, if it doesn't, just kind of sketch the circle where it should be. Okay, but it's supposed to be perfectly inscribed in the triangle. Okay, so here's the next bullet point. The in center, okay, that red dot of the triangle is the center of an inscribed circle about the triangle. Okay, so that's just something that is supposed to work out. Okay, maybe our constructions weren't perfect, but that's how it should have come out, where the circle is perfectly inscribed, meaning it touches each edge perfectly, like so. Okay. All right, so it should go perfectly like that. All right, so that's an inscribed circle, and that it can only be created with the angle bisectors. Let's go to the second investigation. This one's called the perpendicular bisector. So on this one, we're going to construct the 3 perpendicular bisectors. So if you forgot what perpendicular bisectors are, follow my lead, and I'm going to show you. So we're going to construct a perpendicular bisector on each side. Okay, so each side. So remember, it's one big arc like that. Oops, I hope I did it far enough. I don't think I did. No, I didn't. So I need to do that again. So let me undo that stuff. Okay, so let's go a little bit more. Because remember, to do the perpendicular bisector, you have to go more than halfway, right? There we go, I got it. All right, and then we'll do the perpendicular bisector by getting our ruler or our straight edge, whatever you're using. And you're going to draw a line going perfectly through like that, okay? And make sure it's lined up the way it's supposed to, okay? So that's a perpendicular bisector of this side up here, meaning this side's congruent to this side, and then this is a right angle right there. Okay. All right, let's go to this side over here. And I don't like the way that came out. Hopefully I went more than halfway. Yes, I did. Thank goodness. All right, so now we're going to get our ruler and we're going to make that perpendicular bisector. Make sure you line up those intersections perfectly through because you're drawing the whole segment. Okay, some of you are probably wondering, why are you drawing the line so long? Well, look where they're intersecting. They're actually, so the other point of concurrency from our first investigation, it was inside the circle, okay? It looks like as this one's going to be outside the circle, okay? So let's do our one last perpendicular bisector, and that's for this big side over here, this long side over here. So you want to go more than halfway. Let me get my black pen to keep it consistent. More than halfway, so probably maybe like that. That's a little too large. Let me go back. Or I don't want it to be interfering with that. So let me go a little bit larger. Okay, I'm going to keep that. I'm going to come over here to this point. All right, so yes, I know those arcs are rather large, but I didn't want it to kind of interfere with my green lines. So here's what I'm gonna do. I'm gonna line up those two intersections, and look, you can clearly see it is it's gonna go through my other perpendicular bisectors. So just like, I'm just gonna delete this because I want it out of the way. So I realize that all three perpendicular bisectors are concurrent. So let's make a red dot or get your highlighter. So they are concurrent. So that's what goes in the first blank. The three perpendicular bisectors are concurrent. The point of concurrency of the three perpendicular bisectors is the circumcenter. Okay, the first one was called incenter. Remember, I said they all have special names. Okay, and so now it says one more investigation over here off to the right. It says measure and compare the distance from the circumcenter to each of the vertices. Okay, so I want to place my compass on here, and I want to place the pencil on one of the vertices. So see, it's about that far. Now I'm going to come over here and check this one. Oh, it's the same. And this one too. So this one came out pretty good compared to my first investigation. Okay, so this one, if you draw, oops, undo. If you draw an arc there, you'll realize, oh, wow, it goes almost a full circle. If you were to make a full circle, and I know it's kind of interfering with all the writing, but it does, okay? So the compass, I mean the circumcenter, okay, this point of concurrency right here, it is the same distance from each vertex, okay, because you're able to make that circle, okay? So that's what goes on the last bullet. The circumcenter of a triangle is the center of a circumscribed circle about the triangle. That's what you call a circumscribed circle, is when the circle touches all three vertices of a triangle, okay, or really any polygon, okay? All right, let's go to the next investigation. This one is called the median concurrency. So you don't know what a median is, so let's write that definition down first, okay? So it says a segment in a triangle whose endpoints are at a vertex and a midpoint of the opposite side. So let's draw that picture real quick, so that way you kind of have an idea of what this is saying. So just draw a triangle off to the side, and then let's get a different color. So it says it's a segment whose endpoints are at a vertex and a midpoint on the opposite side. So I'm going to draw a midpoint right here. So I'm going to put the tick marks, and so it goes from the vertex to there. That red segment right there, guys, is a median. Okay, it's pretty simple. All right. So now what I want you to do is construct the three medians in the triangle. So we have to find the midpoint of each one. And what do you know? It's the same construction we just finished doing. Okay, so it's kind of like doing the perpendicular bisector, except we're just going to focus on the midpoint only. So we're only going to draw the midpoint. So feel free to pause the video and go draw all three bisectors. Okay, and so really we're not drawing the whole perpendicular bisector, we're just care about that point right there. Okay, so that's the midpoint. So I'm going to do that again over here. I'm going to find the midpoint, and that means I have to go more than halfway and make an arc. Place it on the other end. Make an arc. And then I'm going to construct the one on the bottom too, get it out of the way before I draw my midpoint. So go more than halfway. And this is going to go into the words down here, and that's okay. Oh, no, I don't think I drew that one far enough. No, I didn't. So let me undo this. See, and that happens sometimes, okay? So you think you're more than halfway, but you need to go a little bit more. There we go. Okay, and remember, you're supposed to technically line your ruler up and find the midpoint, but I drew my arcs rather small, so I think I found each midpoint. Okay, so now get your ruler, guys, and draw each median. Remember, the median goes from the vertex to the midpoint. Okay, and this is a new term. Make sure you go perfectly from the angle to the median. Okay, so do that 3 times for all 3 medians, from the vertex to the midpoint. And what do you know, guys? Does it come out concurrent? I think so. Okay, I don't like the way I didn't go perfectly to the angle. I'm going to bring that down a little. There we go. That one's better. Okay, so did they come out concurrent like our other points, our other investigations? It sure did. So let's make that dot red. That is a point of concurrency. So that's our first blank again. The 3 medians of a triangle are concurrent. Okay, what is a special name for this one? This one's called the centroid. Okay, this one's called the centroid. Now, it says with your compass, compare the segment lengths that are created by the division of the point of concurrency. So here's what I want you to do by that, okay? And you can use actually your ruler. We actually don't mind if you use centimeters, but I want you to use the compass first, and then we'll measure with the ruler here in a second. But everybody focus on, let's just focus on this median. Get the measure from the centroid to the edge of the side. Measure that. And then what I want you to do now is I want you to bring your compass up here, go to the point of concurrency, make a little arc there, and then move your compass here. What do you notice right here? It is exactly double the size of this piece over here. You see that? That's how I want you to measure with your compass what that means. Okay? And like I said, you can measure with your ruler too. Okay, let's use centimeters. So watch this. I'm going to measure this little piece right here. This is roughly about, I think, 2.5. Let's see. Yeah, see, this doesn't come out very good. See, so that side might have been a little bit smaller. So this looks like it's about 4.8 or so. And that's like about 2.4. So let me get my pen. So this is like 4.8 centimeters. And this little piece right here was, oops, this one was 2.4 centimeters. You see that right there? So this little piece right here is always going to be half of this piece over here, or double, okay? This one is going to be double this small piece over here. So that's what this median concurrency point, okay, the centroid, does to each of the medians. It divides it uniquely, okay? So like this piece right here, the small piece is half of this one over here. So I can't make it up, so I'm going to measure. So this one is about, let's say, 2 centimeters. So if this one is 2 centimeters, you should know that this one has to be 4 centimeters. You see that? All right, so the centroid of the triangle divides each median into 2 parts so that the distance from the centroid to the vertex, okay, so from the centroid to the vertex, this piece right here, what is this piece compared to the distance of the centroid to the midpoint? It is double or twice the distance. Okay, so that works for all of them. So same thing over here. Let's measure the last one just to be sure. This one should be, so it looks like that's about 2.8 centimeters, something like that. And this one is about 5.6. So 2.8 and 5.6. You see how that ended up being half of that one over there? Okay. All right, so that's the median concurrency conjecture. All right, last one. This is the last one, okay? And we're not going to construct these. We're going to let you just sketch these, okay? So this one's the altitude concurrency. So we're going to sketch the 3 altitudes and the 3 triangles and see how they compare. So this is an acute triangle. So what I want you to do is I want you to get your pencil and just kind of sketch the 3 altitudes. So like this one, would you go straight down like that and make sure that that makes a 90-degree angle, okay? And let's put a little 90-degree because that's what an altitude is. And then over here, we're going to go and just estimate. Remember, you want to make sure that it is 90. So that looks about like that. And this one over here, making sure that it's 90. Oh, wow. It does end up being concurrent. Okay, so put a 90-degree angle there, a 90-degree angle there. Maybe get your red pen. It is concurrent. Okay, so it is concurrent. All right, so those came out concurrent, the 3 altitudes. Let's try it in this next triangle over here. Okay, and this one's weird because the altitudes are going to end up having to be outside of the triangle. And I know you've seen this before, but like so. So you see how this altitude is outside the triangle, when in fact the other ones over here in this triangle are inside the triangle. So sometimes it ends up being outside of the triangle. This one over here is inside the triangle. Okay, so it looks like it'd be something like that. Here's the 90-degree angle. That's what an altitude is. And then the last one ends up being outside the triangle as well. So again, you're just estimating this 90-degree angle. Usually we construct each one. Now these are not concurrent, okay? However, what if I were to extend them and keep them going? So like, let's say this one keeps going straight down. This one keeps going through there. And this one also is extended. Okay, pretty close to it. I probably, again, because I'm just sketching them, I probably didn't. There we go. Let's just make them concurrent, okay? So these are concurrent, and the point of concurrency happens to be outside of the triangle, and that happens sometimes, okay? Sometimes it happens where it's outside or inside. So those 2 points are points of concurrency. And then this last one, let's sketch this last one out. So if I go from the vertex to here, there's my right angle. Okay. So 90-degree angle. And then from this vertex, here's where it gets a little odd. And some students kind of don't understand this. It comes from the vertex. And to be perpendicular to the opposite side is just going straight down. You see how if I can extend it this way, let me make sure I go right at the angle a little bit better. But when I extend it this way, it is a lot not coming out perpendicular. But if I go this way straight down, there it is. Same thing goes for this direction over here. It's going to be straight this way. So the weird thing about this one is that the point of concurrency is actually at the corner right there. That is the point of concurrency for a right triangle. Okay, so these are all the altitudes in these 3 different types of triangles. Okay, so the first blank is going to say is that they are concurrent. Okay, the 3 altitudes are always going to be concurrent. And the point of concurrency, remember, they all have special names. This one's called the orthocenter. Okay, and that's it. These are the points of concurrency for all types of triangles. And usually, like I said, we construct them all, except for this last one, we just went ahead and kind of sketched them. Okay, so make sure your sketches look like mine because they should be concurrent. And that is it.